I'm Sebastian Kaminski. I work for a software company in Ulm, South Germany, and many of our projects are based on Liferay Portal, specifically Liferay Portal Community Edition. And we have very often cases where we need to adapt Liferay Portal for our needs. And it can be sometimes quite complicated if we have lots of modules and we actually need a little bit smaller, simpler version. On one of these projects, I came on the problem that I needed to remove modules from Liferay itself, but it was very difficult without breaking dependencies. So I came up with the idea, why not write myself some help, some tool to visualize the module dependencies and find a way to simply understand which module is hooked to which module and which module to remove. So the motivation for us was we needed Portal, Liferay Portal Community Edition, possibly because we adapted some modules, so we cannot go with the ready modules from the website, just download and run. We have to compile ourselves. And I don't know if any of you compiled Liferay Portal themselves. If you don't change the settings, you get every module included. So everything is there, and you have to take care of it through removing it. So because we had a specific use case, we had to remove the modules, make it as light as possible, and we did not want to break anything, and also we didn't want to give anybody this solution without being sure that the dependencies are not broken, because even if it's on the first start, no exceptions applying, after short term you can get easily very bad exceptions because a user found a way to delete, to change something. One interesting thing are the LPKGs that you get normally out of a package from Liferay. If you download from the website, you, for example, bundle with Tomcat, you have this directory marketplace, and there you may find actually quite a few interesting files, these LPKGs. Those are basically zip files, and in those zip files you find actually the modules of Liferay. And we thought, okay, so why not use these LPKGs, unpack them and use them. The problem is they are very scarce. There is lots of modules in them that we wanted some modules but not the others. I'll show here quickly an example of, this is the Liferay CD web experience. I renamed it to zip in this case, but as you see, lots and lots of modules here, which, for example, of which we did not need. I think one good example is RSS. For example, here, these three modules we actually did not need, but we wanted to have, for example, blog in there. So it did not help us too much because we could have been removing some modules, but we did not know. Okay, we'll break something else. Maybe the API of RSS was used by something else. So what could we do? Our first idea was Gogo Shell. Most of you probably know it. It's a very, very useful tool when you work with OSGi modules. So this is the basics of the Gogo Shell. You just connect with Telnet, localhost 11.3.11 as a port. This is the standard settings. You can list your bundles. You can use diagnose. You can get all the information you need about bundles. Very useful. It gives you actually everything you need because it tells you which services and which bundles are used with bundle IDs. Great, that's what we need. It works, but we get a lot of information. It's a lot of text. It's very difficult to read as a human. So, and you get it one bundle by one bundle, and you cannot really scale it as a human being, just read it through and make it. So we needed to parse it or do something with it to make it modular. First idea was a bash script to run it through, put it into a regex expression, which at some point got so crazy complicated that we say, no, there must be something else. That was not a good idea. Good idea for small things, bad idea for a full Liferay course. Okay. So our next idea is, let's look into the OSGi specification. There must be something, it's OSGi, it knows itself, its own packages. So we say, okay, we imported in our graded project the dependency on OSGi Portal, just to mention, this is example for Liferay 706 GA7. So don't expect 7.1. Might be a little bit confusing, but I think 7.1 we already used OSGi Cover 7. I'm not fully sure. Anyway, from that we looked. Okay, we can get the context of the bundle. In OSGi Core you find this framework util, which is very useful, and you can get actually the bundle that your class is in, and you can get the context from that bundle. From that context, it's very easy to get all the bundles. This delivers you a nice list of bundles, and if you look into them, look within IDE, what is inside there, you cannot really find the dependencies. So if you read the OSGi specification, you will find bundle wires, the full wiring of bundles, and that gives you an excellent tool which allows you to get the connections, get the dependencies from a bundle and iterate over them. You just take a bundle, you need to adapt it to a specific format, in this case for bundle wiring. It's a little bit dangerous because not all bundles will allow adaptation to a bundle wire. So you might get null, you have to check that. It's important because you might try and you will get a direct null counter exception, you will not know, okay, what's happened. But once you checked and made sure that you only get the working bundle wires, you can get the actual, the bundle wiring. You can actually get the actual wires. And these bundle wires give you exactly what we need. We get required wires to package namespace, we iterate over them, and every wire has a provider. In the provider you have a bundle, and in the bundle you have ID, name, version. It's actually extremely useful because you get all the information directly there. So our result was we made a map and made a connection bundle ID to bundle and its dependencies. Okay, but it's bundles. What about services? Services are also connected, not necessarily through OSGi visible as a connection through a bundle, but sometimes actually this bundle is using the service. Yes, it's also possible. You get it directly from the bundle itself. You get services in use, and this service references can be also iterated over, and from there you can also get provider bundle and the information bundle ID. But for us, we thought, okay, that's too much. We don't need it that detailed. It will be very interesting, maybe useful for some people later in the presentation when we start to think about our own projects. But this is already a very interesting thing. But we have a map. We have a map of bundle ID to bundles. What do we do with that? It's still tons and tons of data, a lot. So we thought there must be something. There must be libraries which help you visualize it. So we thought, okay, D3 is a good candidate. It allows you to create a lot of different forms of graphs, a lot of different representations of big data. You cannot go too much over the top because it's a JavaScript library, so it has its limit when it comes to performance. But Liferay as a package collection did not seem to be so bad, so we tried. You find the website d3js.org. It's a library for visualization of the data. So we decided, okay, let's create a portlet, attach it to d3js, and have a look what we can do with that. We decided for a force-directed graph. Basically, it's like a physics simulation. You have nodes and you have connection between those nodes. You add gravity, you add link stiffness and repulsion. And through this, you can simulate the physics behind, and then you need just something to draw it. And D3 also provides you actually tools to do that. The data for it we provided into arrays, which with soil portlet, which we use, is actually quite easy. You can directly provide it into the template, and it's being serialized in the background. We create one array for the bundles, which is just a actually list of all the bundles which we have there. And we have also bundle links, which is a array of objects which have source and target. And those cannot be copies of the elements from the first array. They have to be actually pointers to the first array. So these two are the objects in the first array has to be just the second array has to point to the first array. Yes?
It's for the recording.
Oh, I'm sorry.
It doesn't matter. Doesn't matter.
I forgot. Can you hear me? Yeah.
Okay.
Sorry. So we have these two arrays which we created from our map, which we got through our portlet, and that's what we get. It's not, yeah, it's a mess. It's a hot mess, and it's not really helping. Maybe yes, but before it can help us, we have to do something with that. And actually, it's even funnier if you actually see how it looks in real. If I start the demo, oops, let's hope everything works. A second. So this is actually what's happening. You see a lot of wobbly elements. This is the physics simulation. It moves everything around. So it's not useful. It's something, but it's definitely not what we need. But it's a start. Where's my presentation? It's a start. It's not readable, but what we can do, we can hide actually the most universal packages, which are connected to almost everything. Packages which you really don't want to touch because you know they are the basic, they are the not something like kernel. Okay, it's maybe not. It's also represented as the OSGi module. So you don't want to remove those packages. So let's just hide them and not obstruct our data. We can group the modules in a meaningful way. One idea of mine was to put them in groups by package names. So for example, let's Liferay taglib dot anything past that should be put in one group. I made an experiment with that. It works relatively okay. For this presentation, I did not show the principle, but I think for the source code proof of concept, I might actually also implement that so you can check how it looks, how it works. Might be useful. Definitely an option to click to visualize actually what is depending on what. So what is my dependency and what am I depending on? Also click drag and drop to fix it in a place so we can separate the pieces we work on at the time. And we can move Liferay captcha taglib away from the mess. And through clicking on it, we see that red is what I'm depending on, I think, and the blue one is what is depending on me, all the way around. Not so important at the moment, but it's something that is already helping us in the way that if you know what you are already not needing, for example, RSS or something similar, you can just go and move it out of the way. Let's say I don't need image editor. Not the case. So I move it away. When I move it, D3 allows me to fixate the simulation, say don't move this part anymore. I click on it. Okay, I see it mostly depends on or this is actually what everything else depends on. So many modules depend on this module. So if I click on this one, I see this one depends. The editor web depends on API and depends also on Liferay Portal, portlet bridge soy. So it means, okay, it seems to be a soy portlet. But theoretically, I could remove all this tree here because it's not connected to the rest. So if I did not need image editor.web, I could completely cut off here and get this part out. And I would be almost 100% sure that I would not break a dependency because this is actually the only dependency. And I know that image editor web depends on bridge soy, but bridge soy does not depend on the editor. Done. So this already helps us cutting this piece. Okay, you still have to work piece by piece to get it out. You can then cut it out and make smaller LPKGs that you can distribute and say, okay, if the user needs this, he can add it to his installation and he can have it. Not bad, in my opinion. I don't know what you think, but it's actually a good start. Also, I don't know if you realize the colors I added into this presentation here. Those are actually, I sorted them by the directories on the hard drive. So the green ones is actually OSGi modules. The
Red ones, I think pink or red ones were static. Gray were not found, so probably they are in the main WAR file, war file from Liferay. And for example, somewhere I had blue, that's the WAR war files that are there. So it already added me additional visual help. It's better, but what could we do? Click and drag, that I already say. We can add a little bit more interactivity. I thought for the future to add possibility to just click on a module, on a bundle, and add another button to say deactivate or undeploy. OSGi will cause that if you deactivate a bundle and you have bundles which are depending on it, they will also deactivate, or if you uninstall it or remove it. And that you could use to send me another new map with my bundles and visualize, for example, in let's say transparent or gray, that these bundles have been deactivated through through my action. And yeah, it's for now, it's just an idea, but it's definitely a good thing that I will add in the future for myself. But you have endless possibilities what you can do with that. You have now full information from the system as what modules you have, which modules are active, which not, at which time, and you can make it interactive, and you can do anything what you want with it. You can do this also for your own OSGi-based projects. Most of the custom projects which you will do based on Liferay, you will create it with many small modules, at least that's what we do. We create a project where we have multiple services, multiple APIs, web portlets, and other external components. But sometimes you write the code, or you put somebody on the code, and this person does not really know what he's doing. And sometimes he imports something from a package that you don't want important, and then as a result, you get the cyclic dependency. So it's useful if you have many modules and you need to keep a track, have a look at it. You actually can, in the visualization, add arrows to see also what's happening, so cyclic dependencies are more visible and quicker. But definitely you can quickly look at it and you see what your project is doing. You can see also if you have some really unnecessary dependencies between modules. As I said, somebody who does not know the project and but still tries to develop into it, import something, maybe not necessarily from the API module, but from the service directly, which is bad. So you don't want to do that. As I said, cyclic dependencies. And it definitely is a very small, very simple alternative to big software. I don't know, some of you might know these big players like Structure 101, where it's actually amazing software, very good, but it costs a lot and it's gigantic. Before you even get into it, you have to spend a lot of time just learning it. This case, you might not need to refactor everything in your code. You just want to do smaller refactoring and get just your small project to a point where you just want to see which modules hang on which modules. And one interesting thing is it gave me actually another idea, because I was not sure what I'm seeing with my code is sometimes you get these alone hanging modules. I hope I will find that quickly. Yes, here it is. Sorry for that. I clicked. One example. Yeah, here. For example, ABC ISU GD API. Normally, I know myself that the way I wrote the software, there are modules depending on it. And here, OSGi doesn't seem to know that it's hanging on it. So in this case, the service dependencies come also in play, because some modules will report only that they are wiring to this API, but only through a service, not directly through a bundle wiring. So as to this point, it's actually interesting to know also that you can look into the services. Before because this is actually the main part where I wanted to show you how it works, I want to show you quickly also how we implemented it. It's a very quick proof of concept. So don't judge me too much. I do not have too much time to do it. But what is interesting us is that we just make a simple soy portal. I created with Blade CLI, just from a template soy, adapted it to my needs, renamed, blah, blah. I downloaded D3.js and included it as a header portlet JavaScript. I'm sure you can find it in NPM and connect it as an AMD module, but as I say, we do not really have time. But it's, for the simple portlet, actually does what it needs. So we just attached our D3. In our portlet, in the render command, we just get our bundles through assemble bundles. The naming is also not very nice, but that's okay. In assemble bundles, as I say, we just create our array to hold our bundles, go through the framework user, get bundles. We then get the wiring, import, then we go through the wires, and through the IDs, we add them to our inner class, which I created down here. It's a simple my bundle class where I have only ID, name, version, and depends on, it's a set of longs, so it's the IDs of the bundles that I depend on, or this bundle depends on, and set because I don't need to have 3-4 times the information that I'm depending on the bundle because I'm importing different package from this specific bundle. This way, you can actually put it directly into the template object. I put it here first through a serializer. I was probably very tired at that moment. Normally, you don't need to do it. The maps and list will be very gracefully serialized. I never had problems with that. And on the JavaScript side, we get our bundles map from the OPT config. That's the soy.es.js file. And then we create ourselves these two array files, and I do prepare data. Prepare data just goes through my map and puts all the nodes, all the bundles into the specific arrays, and then links them in the bundle links through the specific object that I had. As I said, I don't create copies, I need to link to them. D3 is very simple if you go do simple stuff, but you can do it extremely complex, complicated, but you can do it extremely powerful. Just as the simplest case where I just visualize the very, very basic is I just created simulation. I give it my bundle nodes as a list, define the forces of the simulation, add tick events, what should happen every tick. I don't know exactly how often they are. I think they are 30 times per second, something like that. So you have a smooth animation. I add forces through the links. The links are the connection between the nodes. And when I did that, I tell this D3 to generate me SVG objects, and for the link to create me a line, for the node to create me actually a circle, only that the node also contains the text. That's why it's as a parent element, and then you get the text. And for every tick, as I say, around 30 times per second, the node redraws itself or translates. It's faster than redrawing, and creates the new position of the nodes and of the links. Through that, we have the very, very simplest D3 for simulation that allows us to create that. So I will be providing the source code for what I wrote, and I probably also extended over time a little bit more. I'll put it on my private GitHub. There is nothing yet at the moment. I will definitely put it on Friday, latest on Friday, there will be the basic source code of what I presented here. You can have a look, you can use it. I think the presentation will be also provided to everybody, so you don't necessarily need to make pictures. It should be available for you. So yeah, now I have, I think, a little bit more time. Yeah, okay. So if there is any questions, 5 minutes, oh, perfect. Exactly. And yes, please.
I have really two questions.
Yes.
About the cardinality, right? Because you only require
yes.
Right?
Yes.
This was somehow the intention, right?
Yes. No, that was That was, yes, that was actually the intention for us for the simple case. We didn't want to make it too complicated. Obviously, you can make it far more complex, much more dynamic. For example, I know that, for example, the dynamic unloading of a module probably would not reflect directly, or at least not properly. So you would have to make a cardinality greedy or dynamic. So.
And the second question is, where do you see like the biggest potential of this model, right? To track down some maybe unnecessary dependencies you just set up, right? But I'm just interested in where do you see the biggest potential of this in like a working environment?
So the biggest potential to this, we did not actually look for the potential. We actually looked to solve our problem. We had the problem to make a smaller, lighter version of a Liferay that we did not have the modules. But we thought, okay, but since we have already this tool, why not use it to help us with regular project? I use that and sometimes look at my project after, I don't know, 20 days. It grew 15 modules. And I don't know actually what happened if my colleague who wrote 3 modules of that did actually the proper imports or not. And it helps me to see it. So I think as for everybody, it's useful to have overview of the project if the project start to grow a little bit out of control.